we're looking at notes K-3, log properties, condense. So in part 1, we are going to be condensing. So that means to write as a single log. So look at number 1. On number 1, we have natural log of 4 plus natural log of x. Since we have a plus in between, that means we're going to condense this to a single log. So natural log of, because of the plus in between, 4 times x. So 4x. Okay, that's number 1. Look at number 2. Log base 4 of z minus log base 4 of y. So again, I want a single log. We have 2 of the same exact log, same bases. Remember, that's the only way you can do this. These were both natural log. These are both log base 4. So I'll get rid of the 2 log base 4s and write it as a single log. Then I have z divided by y because of the minus in between. So log base 4, z divided by y. Okay, here on this, remember you will go backwards, bring that power back up to the top. And this would be log base 2 of x plus 3, the quantity x plus 3 squared. No reason to FOIL or anything like that. Just leave it as is. Okay, look at number 4. So on number 4, 2/3 log base 5 of the quantity x plus 4. So on this one, similar, that exponent comes back up to the top. So log base 5 of x plus 4 raised to the 2/3 power. Okay, and not all the time, but some of the time you will be asked to have no rational exponents. So in this case, for today's lesson, no rational exponents. Okay, and rational, remember, means fraction. So no fraction exponents in answers for today. That won't always be the case. Sometimes you're asked to leave it as a rational exponent, but I want you to get comfortable going back and forth. So in this case for today, no rational exponents. So that means convert this to a radical. So this would be log base 5 of, remember, cube root of x plus 4, the quantity x plus 4 squared. Okay, so we will keep it like that. No need to simplify further on that one. Okay, so now on number 5, again, similar situation where you bring that exponent up. So we'd have log base 10, remember base 10, of the quantity x minus 1 to the 9/2 power. So again, let's for today know rational exponents. Okay, so here on this one, that means log of square root x minus 1 raised to the 9th. Now this one's different from this. Notice here my index was larger than my power here. But I want you to think about for a minute, for example, if you have something like square root of x to the 9th. In this case, since you have x times x times x times x 9 times, you can take out x to the 4th, and that would leave a single x inside. Similar here, you can take out, so this would be log, okay, you'd have x minus 1 to the 4th can come out square root of x minus 1 on the inside. And there's no more power on this, so really the parentheses weren't necessary. If you want to write them in this case, fine, but if not, on the inside only. On the outside, of course, they're necessary, but here they weren't. So if you want to write them, fine, and if you don't, fine too. So make sure you simplify when possible. We could take some things out of the radical. You want to do so. So on number 6, you have log base 4a minus log base 4b plus 2 log base 4c minus 1/2 log base 4d. So again, condensed to a single log. I forgot my equals sign here again. So I just want a single log base 4. So on this you have log base 4, a in the numerator, Okay, I'm going to leave a lot of space because I know I have a lot of minuses here. So it looks like b's in the denominator. C squared, because of the plus sign here, is in the numerator. So remember that 2 comes up as a power. And because we have a positive in front, this would be c squared in the numerator. And then because of the minus here, the d to the 1/2 power would be in the denominator. And then again, remember, no fractional exponents. So we're going to clean it up and rewrite for a final answer here. Log base 4. The ac squared on top is fine. The b is fine on bottom, but we're going to convert that to a square root of d. Remember, index of 2 implied here, power of 1 implied here. So that's our final answer because we want no fraction exponents. No rational exponents for this lesson. All right, so look at number 7. So first thing I want to point out on number 7 is you have this -2 here with the brackets. So that -2 is going to distribute right in front of that natural log as well as in front of this natural log. So let's rewrite first. We would have ln of x minus 2 ln of x plus 2 minus 2 ln of x minus 2. So now again, you want to condense to a single log. So we don't want 3, we just want 1. Natural log of x on top, and because I know a lot of stuff's going to be on bottom because of all these minus signs, I'm leaving a lot of space. X on top because there's a minus there. The x plus 2 squared will be on bottom. Remember that 2 comes back up as an exponent. Similar here, that 2 comes back up as an exponent, and x minus 2 squared would also be on bottom. And in this case, we have no fraction exponents, so we're good. We don't need to simplify anything else. Okay, so just one more of these type. Number 8. So here, similar situation where you need to distribute the 1/3 to all the natural logs. So this one, and that one. Okay, so we would have 1/3 times 2 is 2/3 natural log x plus 3 plus 1/3 natural log x minus 1/3 natural log x squared minus 1. Okay, so now we want to condense to a single log. So get rid of the 3 and make 1. Natural log of, on top we're going to have x plus 3 raised to the 2/3 power. Okay, also on top times, because of the plus here, x to the 1/3 power. So that 1/3 becomes an exponent. We know because of the minus here, we'll have over this x squared minus 1 gets raised to the 1/3 power. Okay, so again, we can't have the rational exponents. What you notice, hopefully, is that all denominators are 3. Okay, so since all denominators are 3, that means you would rewrite as natural log, and all of them would be under a cube root, x plus 3 squared times x to the first, or x, right? You don't really need the 1, it's implied here, over x squared minus 1. And again, this last step that you probably want to do, I know I want to do, is bring this single x in front. Oh, that was supposed to be a cube root, wasn't it? Because the denominator was 3, so cube root. So cube root of, in front, x times the quantity x plus 3 squared over x squared minus 1. And really this x squared minus 1 doesn't need to be in parentheses. If you want it to be in parentheses, so that way you are telling yourself you cannot by any means simplify these, either of them, with this. This is joined. If you need the parentheses to show you that it's joined and you can't simplify, then keep it, but I like it without. All right, so now last section here, Roman numeral 2, evaluate. We've been doing this, we just haven't been doing it like more difficult problems, but we've been doing this. So your plan is to swirl, make the bases the same, and equate exponents. So remember, I've talked about multiple times in the past, if you have log base 3 of 9, I always say, what power would this be? 3 to what power equals 9? Okay, you can put an x there to help you see. That's our unknown. So then if you convert this using the swirl method, if you convert that, this would be 3 to the x power equals 9. So swirl, make bases the same. 9 can be rewritten as 3 squared. So if our bases are the same, the exponents must equal each other. So then you equate exponents. So x equals 2. So therefore, our unknown is 2. 3 squared is what equals 9. Okay, so we've been doing simple ones like that. What happens when you have something like this? Well, you still should be able to figure this out if you say equals x. So 3 to the x power equals 1 over 27. So rewrite 27 to have the same base as 3. So 3x equals, remember 3 cubed is 27, so 3 to the negative 3 is 1 over 27. So then if bases are the same, exponents must be the same. So x must equal negative 3. All right, on this one you can't evaluate and you can't swirl until you have a single log. So condense this to a single log. So this would look like log base 5. Because we have the minus sign, this would be 75 over 3 because of the minus. So then convert this to log base 5 of 25. 75 divided by 3 is 25. And then you can go ahead and swirl. Once you say this equals x, our unknown, 5 to what power? 5 to the x equals 25. So 5 to the x equals 5 squared. 25 is 5 squared. And then x equals 2.